Hello everyone, my name is Kuncarlito Oum. I'm a sophomore in civil engineering at University of Paragon. So today I'm going to talk about PermaLearn platform. So what is a PermaLearn platform? Another word for PermaLearn platform is a 2D structural analysis tool. It's a free platform designed for student, engineer, and educator. Its goal is to make structural engineering more fun, accessible, and enjoyable. Through a PermaLearn platform, a user can explore and visualize and solve structural problems easily without needing or using expensive software and struggling with complex equations. It's designed to help students learn the fundamental of engineering and to understand more about the structural of engineering. So to understand and deeper and in depth of the platform, we use an example from the book to apply on it. I choose 715. It read that determine the internal normal force, shear force, and moment at point C. So as you can see in this exercise, we are analyzing a 6 meter supported at both ends, 6 meter beam supported at both ends. At A is by roller and B is pinned. The point of interest is point C is located at the middle of the beam, 3 meters from each support, and the beam is subjected to a triangle distributed load that starts at the maximum intensity of 6 kilonewton and taper down to zero at B. So the objective of this problem is to determine the normal force, the shear force, and the uh, bending moment. So before we going to apply this exercise into the platform, we have to understand what is the normal force, shear force, and moment. Um, as from my understanding, a normal force is the definition of normal force is the force that acts along the length of the beam, and it's called internal because it's inside the material and the push back against whatever is trying to stretch or compress it. And shear force is the definition. This is the force that acts perpendicular to the length of the beam. It tries to slide one part of the beam past another part, like tearing in action. And a moment, the definition of moment is the bending moment is the rotation force inside the beam that causes it to bend. Now, now let's apply our exercise into our platform. So as you can see that our beam is 6 meter long. So we put the beam horizontal at and next part we choose A and B. As we know, A is supported by is support as a roller and B as a pin. So we choose a joint coordinate and we choose A and we choose supported type as a roller and we add. Next we choose another point is B and supported type pin. As you can see that our beam is supported by A roller and supported by pin. Next part is we try to find the force. The force is 6 kilonewton from A taper down to 0 to B. So we go to linear distributed load and we choose our beam and we choose a loaded type, vertical load, and we can load from 6. We choose -6 because the load is pushing downward. So that's why -6. And as you can see that our as our example is the same as our exercise. Now, to find our objective is to find the normal force, the shear force, and the moment. So we go to solution. First is a normal force. As you can see that our normal force is 0. Next is shear force. Our shear force is negative 1.5 kilonewton at point C. And next is our moment. Our moment at point C is 13.5 kilonewton. So as we find our objective, which is the normal force, the shear force, and the moment, this has come to the end of our video. Thank you for watching.